This is problem number 3 from section 3.2. In this problem, they say find the derivative with respect to t if s equals t over 4t plus 5. So they want us to find ds over dt, and we know we're going to do this using the definition, which is limit as h approaches 0, f of x plus h minus f of x all over h. So we're going to start plugging in x plus h into the function, and we end up with limit as h approaches 0. We'll get x plus h over 4x plus h plus 5 minus the original function, which will be x over 4x plus 5. That's all over h. Now I think it makes sense, the first thing that needs to happen, probably distribute the bottom, and you'll notice that I need to multiply the right side by 4x plus h plus 5 and the left side by 4x plus 5. So let's go ahead and distribute that. And we get x plus h over 4x plus 4h plus 5 minus x over 4x plus 5. Now I want to combine these fractions on top together. So let's multiply this side by 4x. So we're going to multiply this side by 4x plus 4h plus 5, and this side by 4x plus 5. So we're going to get the limit as h approaches 0, and when we multiply, we'll have 4x plus 5 over 4x plus 5 times x plus h over 4x plus 4h plus 5 minus x over 4x plus 5 times, and now we'll multiply by the other denominator, which is 4x plus 4h plus 5 over 4x plus 4h plus 5. Go ahead and put some parentheses around this stuff. Now when you multiply those, on the top I'm going to go ahead and distribute. So I'm going to take the 4x plus 5 times the x plus h, and I get 4x squared. Let me write limit again. So I get 4x squared plus 4xh plus 5x plus 5h. Now we're combining these together because we have the same denominator, right? So we're going to have minus, and I'm going to distribute this x value, this negative x, to each term. So it's minus 4x squared minus 4xh minus 5x. That's all over 4x plus 5 and 4x plus 4h plus 5, because we combined the two fractions together. Now I forgot to put something in here. This is all over h in the previous step. So this is all over h as well. All right. Let's go ahead and take the limit as h approaches 0, and let's combine some stuff together. So 4x squared cancels the negative 4x squared. The negative 5x cancels the 5x. The negative 4xh cancels the 4xh, and I'm just left with 5h over 4x plus 5, 4x plus 4h plus 5, and that's still all over h. Now up here I'm going to go ahead and say, essentially I want to multiply, I want to divide, I have a fraction divided by h. This could be put over 1. So I could put it over 1. I'm going to multiply the bottom by 1 over h essentially, the top by 1 over h. And all that really does is combine the denominators together. So I end up with limit as h approaches 0 of 5h over, this will end up being h 4x plus 5, 4x plus 4h plus 5. Now the h's cancel, and I'm left with 5, so limit as h approaches 0. I'm left with 5 over 4x plus 5 times 4x plus 4h plus 5. Now when I evaluate h at 0, I plug it in. This cancels. I'm left with 4x plus 5 and 4x plus 5 on the bottom, which is, this would be 5 over 4x plus 5 times itself means I'm squaring it. So I can say ds over dt. Now I can replace the x value with t essentially, and that's going to be, that would be 5 over 4t plus 5 squared. So the derivative with respect to t is 5 over 4t plus 5 squared. This is the expression for the slope at any point on this line.